this. Yeah, now let us continue with our question. We're done with 11.1.1 to 11.1.3. Now we're going to 11.1.4. The question says, calculate the amount of charge. The amount of charge that flows through ammeter A1 in 120 seconds. That is the time, 120 seconds. So now they want the charge, they want Q. They gave us the time, they want Q on A1. Where is A1? This is A1, this is the ammeter A1. What is the current that was read by ammeter A1? The current was 2 amps. The current was 2 amps. So we do have the current, we do have the time is 120 seconds. Now we want Q. So what is the formula that we use? From the previous videos we said the formula for the charge says, is it 11.2? Okay, 11.1.4. This is 11.1.4. So the formula says I is equals to Q over delta T. That's what we said on the first video. So we want the charge now on ammeter A1. We said the current is 2. We want the charge, the time is 120. And the time is in seconds. The time has always been seconds. This 2 is over 1. So we cross multiply. Q times 1, Q. 2 times 120. 2 times 120, that is 240. The charge is in coulombs. The charge is in coulombs. Just a quick check. 2 multiplied by 120. Okay, my calculator is frozen here. But yeah, you can verify on your own calculator. 2 times 120 is 240. So that means the charge passing through this ammeter is 240 coulombs. So we're done with 11.1.4. Now we go now to 11.2. How will the reading on ammeter A1 be affected if 6 ohm resistor is removed from the circuit? How will the ammeter A1 be affected if 6 ohm resistor is removed from the circuit? In other words, if you remove this resistor, what's going to happen now to this current of A1 if you remove this resistor? So let me give you a picture of what they are saying here. Now let me use this circuit again. I'm gonna show you a picture of what they are saying. So I'm gonna erase all of this. Erase all of this. Okay, yeah. Imagine now this is your 3 ohm. Then this is your 4 ohm. Now the 6 ohm has been removed now. We don't have a 6 ohm here. And then on this other side, we have that ammeter, which is ammeter A1. We have ammeter A1 here. So imagine we have ammeter A1. Yeah, this is ammeter A1. So it's still our battery, 12 volts. Now they are saying now what's going to happen to this current now of A1 if we remove that resistor. So if you remove the resistor 6 ohm, then the R total now is going to become 3 plus 4. 3 plus 4 is 7 ohm. But previously, the R total, if you remember, R total was 2 plus 4. This was 2, this was 4. So R total was 6 ohm. But now R total is 7 ohm. If you remove 6 ohm, R total becomes 7 ohm. In other words, R total is increased. So if R total is increasing, what's going to happen to A1? A1 is going to decrease. How do we know that? Let me show you. This is how we know that it's going to decrease. I'm going to show you how we know it's going to decrease. Let me create a space here. So the formula says I is equals to V over R. This formula says I is directly proportional to V. If you can see, I is a numerator, the voltage is a numerator. If the voltage is increasing, that means the current is also increasing, because they are both numerators. In other words, they are directly proportional to each other. But if you increase the resistance, the one that is in the denominator, then the current will decrease, because the current and the resistance are inversely proportional to each other. This one is numerator, that one is denominator. If this one increases, then the current decreases. But if voltage increases, current increases, because they are directly proportional. But the current and the resistance are inversely proportional. If this one increases, this one decreases. That's what we saw from the diagram. When you remove the 6 ohm, when you remove this one, resistance increase. If resistance increase, then the current will decrease. So that's what they are asking here. So let's look at the question again. How will the reading of ammeter A1 be affected if the 6 ohm resistor is removed? Write down increase or decrease or remain the same. So we choose which one? We choose decrease. That ammeter will decrease. So we choose decrease. Then we get our 1 mark. Then check 11.3. Now explain the answer of question 11.2 without any calculations. How many marks? 3 marks. So there are 3 sentences that you must write to explain why you said the ammeter will decrease. So we must write words there. So this is how you write those words. So 11.3, we say now, when the 6 ohm resistor, is removed, the resistance of the circuit will increase. We saw that it increased from 6 ohm to 7 ohm. That's correct. Then if resistance increase, the current will the current will decrease. That's correct. Why? Because the current is inversely proportional to the resistance. That's your 3 marks. When the 6 ohm resistor is removed from the circuit, the resistance of the circuit will do what? It will increase. Then if the resistance increases, the current will decrease. Why? Because the current is inversely proportional to the resistance. So that's how you answer that question. So yeah, we are done with this question. Let us do now another exam question on electric circuits.